Okay, we just started talking about foliated rocks, the fact that they have leaves in them, which are caused by pressure from left or right or by shearing. And this is what foliated rocks look like. Now, slate doesn't look too foliated. The minerals are just starting to line up in it. But you can see that it easily breaks into thin little sections. Why is this handy for us? Well, here's a slate mine. Man, you get dirty doing this kind of stuff, but they have to wet everything down, otherwise you get dust in your lungs and that's not good. They cut up these big chunks, they put it in these loaders, they haul it to the surface, they slice it with, well, remember what diamonds were most commonly used for? Saw blades. And then they make it into thin little pieces. What do they do with these thin pieces? Who knows what this is? Yeah, you, there with the headphones on? That's right. Take a look. 6 holes in this, 4 in the corner, 2 on the sides. This is a slate pool table surface. The best slate pool tables, or best pool tables, have a 1-inch or greater slate surface because it doesn't warp. If you've ever had a plywood or particle board pool table, you know what it's like when you shoot your ball. It goes all over. If it's your table, it helps you. If nobody else has played on it, they're at a disadvantage. We used to take these slates and make them into chalkboards, which is why they were called blackboards, because slate really is a dark stone. We would stick this onto the wall, but you had to have really strong walls in order to do this. And then every once in a while, one of these would fall off and you'd end up with a really short student. That wasn't good. Okay, maybe not that part, I made it up. But students would carry around their own little pieces of slate. They would put their lessons on them, and no matter how they did, at the end of the day, they would erase it, and they would start the new day with a clean slate. That's where the phrase starting with a clean slate originated. Now, slate can get squished into phyllite, which is essentially leaf stone. In phyllite, the minerals are beginning to separate just a little bit more. In this case, somebody's tried to write their name on there with a penny. But you start seeing how it's separating into foliations. Phyllite can become a schist. Here's a better schist. In this case, the mica is separating back out. Extra credit to the first person who can figure out why I put that person in there. Just email me. Here's another type of schist. And then schist can get squished into gneiss. Let's go through this one more time. Shale can become slate. Slate gets squished into phyllite. Phyllite, by the way, is the rock that's all around 7th Street south of Thunderbird. If you're hiking around the North Mountain area, there's a lot of this kind of rock sticking up in the air. In fact, because the rain gets down in the phyllite, it expands the clay layers in here and makes it slump off onto the road. And that's why going down 7th Street, you see all those concrete barriers to keep the phyllite from plopping onto the road. Okay, phyllite can change to schist, and schist changes to gneiss. This is a really nice example of gneiss. Now, this is the kind of rock that's over by 7th Street and Thunderbird, just south of there. This isn't that location. Here's a guy in 80s shorts looking at a nice piece of gneiss. Whoa, what's going on here? Looks like it's been folded or something. Rocks can't fold, can they? This is also very, well, you can say it, I'm not going to say it. Okay, another weird rock, amphibolite. We don't care about it. I won't ask you about it. Just know that there are lots of weird rocks that occur in metamorphism, and we're talking only about a few of them. Now, how can you recognize a metamorphic rock? Well, the obvious thing is foliations. Foliations. The next thing, folding. And I'm not kidding. Rocks that are metamorphic really do fold. This is General Carrera Lake, Chile. This is limestone that's been forced into marble and then warped. It's just beautiful. You can tell the lake goes up and down and then eats away at the marble. In an earlier chapter, you learned that marble is soluble in slightly acidic water. If rock is underground, not near the surface, instead of breaking, it will bend over time. Take a look at these rocks in the Jura Mountains in Switzerland. Crazy bending going on here. Why? This is all caused when Africa accidentally bumped into Europe. Excuse me, Europe. And over millions of years, you end up with folded rocks, and those folded rocks have to be lifted up. Take a piece of notebook paper, put it on your desk, put one hand on the right side, one hand on the left side, and push it together. The middle of it pooches up. Same thing happens to rocks, creating the Alps. Why do we care about metamorphism? Well, one, strange people take their unicycles out and they actually ride on this stuff. This is riding the unicycle out in the McDowell Mountains, and this rock is a lot of phyllite. They're my buddies. We also mine metamorphic coal. Anthracite coal is bituminous coal that has been squished into a really hard rock. It has the most pure carbon and therefore the highest degree of energy in it. It's the cleanest burning. Not that coal is ever clean, but it is the cleanest burning form of coal. Here's a cool little thing. A guy I knew and helped me on my master's project, Gene Shoemaker, geologist with the USGS in Flagstaff, discovered what is called shock metamorphism. This is west of Winslow, Arizona, my hometown. And this is all sandstone around here. But right next to the crater, it's not sandstone anymore. It's quartzite. When, 30-something thousand years ago, a large piece of rock made it through the atmosphere, unlike the big rock that was just over Russia. Actually, some pieces of it did get to a lake, huh? This rock hit the earth, made this rather large hole, and changed the sandstone around the edge here into quartzite, called shock metamorphism. Now, here's something important. Excuse me. Shale can change to slate. Slate can change to phyllite. Phyllite can change to schist. Schist can change to gneiss. This is kind of a PG-13, so don't let your parents know about this. Shale can change to slate, the chalkboard stuff. Slate can change to phyllite, the rock that's over by 7th Street and Thunderbird, or up in the McDowells on the Gateway Pass Loop. Phyllite can change to schist. Schist can change to gneiss. The way to remember this, if you went to a restaurant and had some shells, like snails or crabs or something like that, they were put on your plate, and you ate them until you were filled, and then you had to go to the bathroom, and then you felt nice. So shale changes to slate, changes to phyllite, changes to schist, changes to gneiss. You had some shells, they were put on your plate, you got filled, you went to the bathroom, and that felt nice. Where does this kind of thing happen? Way under the ground. We're never going to get a photograph of this, because this rock called migmatite is like a super gneiss. Whoa. Here's an example of where hot material has been forced into rocks. This is New York's Riverside Park. And this, if you remember earlier, is an intrusive volcanic dike where hot material was injected into previously existing limestone. This black rock is a very stained limestone, and right here, that's where the limestone has been baked into marble by this, the basalt. That's all, folks.